Okay. Hello. Good evening, everyone. Thank you for being here. Well, it is a pleasure to introduce Andrew Whalley tonight in the context of Climate Week. I think Andrew actually is one of the architects that falls in the category of not needing an introduction. We find ourselves often discussing buildings that he's worked on. Just to say a few, like the Eden Project, even the Waterloo, which I know it's like a long time ago, but the Waterloo and the Paddington terminals, or the Sustainability Pavilion, which I think it's in the image right now in Dubai, just to name a few. So it's interesting how his career alongside both academia and practice, but of course sitting in the Grimshaw office, bridges a lot of the research between different worlds and different discussions, and I think that's what makes it especially relevant today to see how the work permeates into the different spheres. Andrew, of course you all know, but he is also office chairman at Grimshaw, which means, and that to me is very interesting, that he reflects about the ethos of the practice and the reach of the practice outwards. And he's involved in academia also, generating not only discussions, but advice, I think, for new programs. Maybe he will not touch upon that literally on the talk, but we can expand on that in the questions. And to be honest, I think we want to hear from you. The floor is yours, and thank you so much for being with us.
Thank you. And Mike told me apparently we have a few people in this modern world we live in watching online. So for those who aren't here but virtually here, welcome as well. So I won't use the full, don't worry, I won't be talking for 90 minutes. We'll be less than an hour, I am sure. And an opportunity, it's a nice small group to have a discussion. And hopefully a few of you can join us upstairs and carry on the discussion maybe over a drink. So I know with Mike curating this Climate Week, that I've very much focused my talk tonight about our work and experience designing environmental architecture or the interest in sustainability. And actually I had the opportunity on Monday of speaking at the UN as part of the week that's happening there on decarbonising the urban environment. And some fascinating talks. But one of the takeaways, I think, which was fascinating, is that the planet, which we're going to talk a little bit about, is a finite thing with finite resources. And bar a few elements such as helium that can escape the gravity of Earth, everything we have is here. That we won't be able to make anything more. So we're using and working within a set limit. The amount of carbon that's here is already here. It's just a question of what we do with it and how much we release into the atmosphere. So we must always think that we're working within, hopefully there will be generations that follow us, and we need to leave them material to work with and leave them a planet to work with. And I mention that because, and many of you may be familiar with some, I hope are familiar with some of these statistics, you should be, to do with the challenges that we face. And reflecting on that, if you think about the planet's history and 4 billion years, I mean, when you get into billions, well, apart from Jeff Bezos, billions are a difficult thing to work with, aren't they? And I can't imagine 4 billion years. So if you think of the planet's 4 billion years as a year, to think about what our impact has been, and the fact we've created almost a new era, the Anthropocene, the first species to actually create an impact of the planet in that way, then really, as a species, we've only been on the planet. If 4 billion years was a year, we've only been here 15 minutes before midnight, and actually recorded history 30 seconds before midnight. So think of that in the context of a year. And the Industrial Revolution would be then, on that basis, 1 second. So if you think the impact that we've had in the last 2 or 3 generations is probably about a quarter of a second in a year of the planet's life, and that's the impact our species has had on it. So I think we need to reflect on that, and then we need to reflect on what the UN are predicting as our current future. So the current predictions are that by the middle of the 21st century, and we're already a quarter way there, we will double the population living in cities. So in other words, a third of the people that aren't yet here, all of those people will be in cities. So we're already an urban civilization. More than half live in cities. It'll be almost double that in 2 generations. So what that means, if you think about it, is that we're going to have to duplicate our entire current urban infrastructure. So everything that you know of today, there will be the equivalent of another London, another New York, another everything, because that's what double means, quite simple. So, to put it proportionally, and these were kind of the facts that were being banded around earlier this week at the UN, but it's the equivalent of constructing every building in Japan, which is 230 billion square meters. Again, it's a difficult figure to imagine, but every building in Japan every year for 6 decades. Again, I find that difficult. An easier one, I think, perhaps, is thinking of building. It's also the equivalent of building 1 Manhattan a month. So that's 12 Manhattans a year for the next 60 years. So, that's the scale of impact. So that's against an already increasing levels of CO2 in the environment. And I want to broaden it beyond just carbon and energy into a much more holistic approach and view of the planet. But we've got to seize an opportunity. And 80% of global GDP is actually generated in cities. So if we're going to double our cities, that's actually an opportunity, because we're going to be generating a huge amount of wealth. It's a question of how we use that wealth and how we direct it. And of course, part of what's going on with that rise of population and with urbanization is there's also a rise in affluence. And by that I mean more and more people are being pulled out of the poverty line and having better qualities of life. And so we want everyone to have that. But the only way we can actually deal with the challenges that we have, I think, is to increase productivity and efficiency. And so as architects, we've got a real role to play, I think, in innovative thinking. And I'm going to use the word a few times, ingenuity, because it's not about invention and technology. I think it's about using our brains. So some time ago, quite a long time ago, 2 famous scientists put down the problem in this very simplistic kind of formulaic way, I equals PAT. And what they were saying was effectively that the human impact on the planet is the factor of 3 things: population growth, affluence, that's our consumption of materials, and the only way it can be balanced is the interrelationship with technology. And I would actually push that one step further. I mean, yes, technology, but I would say actually more interesting enough is ingenuity, is the way we can do things differently. So at the UN, categorically have stated that we need to deploy, and if we're going to avoid catastrophic climate collapse, we need to deploy a low-carbon design approach. So basically all our buildings, all our new buildings, need to be carbon neutral by 2030. That's their current policy. And actually all current buildings need to be retrofitted with a deep retrofit by 2050. So there's some major tasks to take on. So we, some time ago, signed the World GBC's net zero carbon commitment. And actually, when I took the reins from Nick in 2019, I made a commitment. I gave the opening talk at WAF, World Architecture Festival, and we made a kind of commitment that we would be carbon neutral as a business by 2020, and that we would design all of our buildings as net zero ready by 2025, and aim to get to regenerative design by 2030. So this is our little kind of timeline, if you like. And so we're holding to that, but it's actually it's taken quite a bout of commitment from our side, which also means actually turning down work. It means really following through on what you believe in. And as I mentioned, for me, it's not just about carbon. I mean, years ago we used to talk about energy efficiency, embedded energy. Now it's embedded carbon. It's all the same thing, but it's actually about our whole impact on the planet. And I've had the good fortune of working with a guy called Professor Johan Rostrom, who was originally from the Stockholm Institute of Resiliency, is now also with Max Planck Institute. And he, with his colleagues, developed the idea of planetary boundaries. And so it's looking at all the human impacts on the planet, which goes beyond just climate change. I mean, novel entities are materials that we don't even know the impact. So for instance, nanotechnology, which on the surface of it has great opportunity. So it's now being used to paint planes, because instead of having a kind of certain weight of paint, they now have a very, very thin layer of paint using nanotechnology. But the material that doesn't stick to the plane then goes down and gets washed away into the groundwater. And no one actually knows or has researched what the impact of nanomaterials in our environment, in our digestive systems, is going to have. And it was only working with material scientists, I was really taken aback by the fact that only around 20 to 25% of materials are fully tested. Many materials just come directly out, and we are the guinea pigs. So that's why we get things like asbestos and so on, because we don't actually test materials until they go wrong. So I just thought, as many of you I hope are students here, I thought I'd do a little prologue. So I had the good fortune of doing my diploma here at the AA, and I was with Jan Kaplitsky and Ron Heron in Unit 8, if I remember rightly. So I have a little prologue, just for fun, before we really get into the meat of things. So when I was here, trying to push the boundaries, maybe my naive parents said, "Can I design them a house?" And a very tight budget, £65,000. So it was actually a dose of reality at the same time when I was also doing my diploma thesis. And so I designed, with my wife, very simple courtyard house in Scotland for them. But even then, I've always been interested in sustainability. So as a kid, I used to build solar heated panels and that sort of thing, and experiment. And so the idea of the house was it was passively heated, because actually in Scotland you get a lot of sunshine, but the ambient temperature is low. And so my thought was, if I could capture that in a courtyard that you could open and close as a garden, that you could actually then temper the house. And so it was designed very simply with a glulam structure framework. And then also, I've always been interested in materials, so it had a new glass technology which had been invented in Finland, which is electrically heated glass. So the low E coating had an electrical charge put on it, which neutralized it as its U value, and then highly insulated glass. So basically, the building was in a kind of conservation area. So outwardly it was a kind of stone building. Inwardly it was a very glass and glaze building. So my parents lived there for many years. A while ago it was sold, so I actually managed to pick up this. So this is just 2 years ago. So I built this in nearly 40 years ago. So here we are. So, and we're going to have a little epilogue at the end where we finish in the same village where I was brought up in Scotland. So those are the Ochil Hills in the background. And here we have the little house. So outwardly, it's surrounded by a stone wall and reclaimed slate from an old disused building, which was part of the conservation deal. But inwardly, of course, it's just all glazing. So yeah, excuse the graphics. That's not me. And then so it was translucent glass. Very simple. I remember I think the framework cost about £1,000. I remember the glass wall was £12,000. I can also to this day remember the whole breakdown. But it's a very simple house, but actually worked really brilliantly for them because it's one big open space that you could then open and close. So they've since changed, and buildings have to change. They have to flex. So the new owners have converted what was the central garden into a music room, which is works for them and actually probably works quite well. There you go. Originally, there's central court. Originally, the central courtyard was actually a garden with a pond and so on. So it changes. And the site was actually extremely difficult. We got it very cheaply because no one wanted to build on it because it had a mine from the late 1700s. A drift mine went right through it with water coming up out of it. So the mine shaft was long since gone, but we managed to find a way of building with a kind of floating foundation. So then after doing that, my wife and I decided, well, why don't we do our own house, which we did in Finsbury Park. So really learned from my parents and then used that again to develop our own house, which again was a glulam building. This is now in the mid-90s. Yeah, I was teaching at the A. So it was, I remember, £130,000 all in. But again, a glulam structure faced the street, so we had to have a kind of translucent wall facing south. And then a central courtyard, and again it used passive solar heating. So the central courtyard had a lot of thermal mass that captured the heat. And then we had a kind of Scandinavian air exchange system that took all that heat and used it to pre-warm the cool air coming in. So we basically built it ourselves with specialist contractors coming and doing different bits and pieces. And again, I remember the frame was £2,500, glulam. Couldn't afford Douglas fir like my parents had, so we had to settle for white fir. But nevertheless, it was a fabulous building, and we really enjoyed living there and raising our family there. But unexpected things happened, and we found ourselves moving to New York. So there we go. So anyway, that's my little prologue of things you can do yourself, and encourage you all to do the same thing in your own time. And actually, when you do things for yourself, you really learn, I think, more than when you do it for others. So I'm going to talk about the last 4 decades at Grimshaw. So I've been there. I graduated in '86 and joined Nick at what was a 12-person practice. Now just over 600 around the world. So it's kind of evolved during that time, and so is the work that we've worked on. So really, when I joined, certainly in the late '80s, it was mostly industrial architecture that we did. And then really, by good fortune, being an architect is often about fortune, winning competitions, or just being at the right time at the right place. And we were very fortunate. We did an exhibition that got us in the right place at the right time to win Waterloo. So a little 12-person practice found themselves doing the biggest infrastructure project in the country at the time. And I had to learn a lot of things very quickly. But we then went on to win the British Pavilion at the World Expo, which I'm going to talk about, and the Eden project, and so on. And so we've always had an interest in the impact architecture has on the environment and how it should respond and how that informs its vocabulary. And as the practice has grown, so have the kind of scale of projects, particularly in infrastructure following Waterloo, which I'm going to talk about their impact as well as we go through the different projects. But you'll read on the top right-hand side, as each decade goes on, how the level of the population grows, the CO2 grows, and so whereas we might be interested in the environment, sadly, most of the world isn't, hasn't been, but is slowly waking up. And I think one of the challenges we have is how we turn the tide, which is how I'm going to kind of what I'm going to talk about at the end. So I thought I would just pick up and look at a number of projects and just pick up on aspects of those projects just to explore. So my first topic is harvesting the sun, which of course is a free resource you can use in all sorts of ways. And really that's one of the things we did with the British Pavilion in Seville. We wanted to explore what would an architecture that responds to, and this was the late 80s when we designed it, and there was an awareness in Europe, I think, on the impact buildings had on the environment. And so we were interested in exploring how could that inform an architectural vocabulary, how would that respond? And it was a competition, so we won the design competition. And I've always enjoyed this little sketch of Nick's, because I remember meeting him in his kitchen as we were talking about the project, and he brought this sketchbook out which had this little sketch in. And the beautiful thing is actually the building, you can read the entire building in that first little concept sketch. And the idea was actually, rather than trying to air condition, Seville is the hottest city in Europe, rather than trying to air condition the entire space, what if you create a layer, a buffering layer, and then just condition it and cool it slowly? So, it's actually quite comfortable if you've got a large space and you drop the humidity to be in the 80s. You don't need to be in the kind of early 70s. And then the exhibits themselves could be contained in lower temperatures. So the building had to be built in the UK. That was part of the condition, and then built very quickly in Spain. So, often I think we've drawn on different technologies. Here, there's always been an interest in yachting technologies because they tend to be, very lightweight, use fabrics, very easy to assemble. So the majority of the building was actually layers of fabric. Both particularly on two sides. On the back, it was actually built by stacking up disused shipping containers. And the huge benefit that had, apart from they're very easy to get and stack, is that we filled them and it created a massive thermal mass that allowed us to use it to cool the building at night time. We basically used it to absorb heat during the daytime and then recool during night. And the main feature was the west-facing wall. And so there, it was probably one of the first uses, I think, of photovoltaics, which we had to borrow from BP. It was early days. And they powered pumps that pumped water that then poured down the wall. So it created this sort of, I think, calm oasis that you could go into. Yeah, so this takes you back. Now, the reason this is so fuzzy is this is, for you youngsters, this is called VHS, which at the time was the height of technology. It was a cassette about that big. But this is, anyway, but it at least lets you, because the building, of course, no longer exists, but you can see the impact of going inside the building in this water wall and the feeling of coolness. And of course, unlike a brise-soleil, which cuts out all the light, the lovely thing about the water was that it cuts out the infrared only, and the whole visible spectrum comes in, but with no heat. So the amazing thing was when you stepped inside, it was so cool, and all you heard was this crashing sound of water. And for me, architecture, there are technological edges and parts to it, but also it must be beautiful and it must be a sensuous experience. And we actually often use the term to try and encapsulate what our goal is beauty through ingenuity. So ingenious design naturally leads, in my mind, to a beautiful outcome. So another big inspiration for us, I think, has been inspiration from nature. And I remember as a student, both when I was at Glasgow School of Art and also then at the AA, I used to spend a lot of time in the library with Fry Otto's Institute of Lightweight Structures. And there was an amazing collection of books where he explored all sorts of, basically learning from nature, whether it was spiders, webs, or bubbles. And we're going to talk about bubbles now. So I've also had the good fortune on certain projects on having the opportunity to research. And following Eden, we've worked on a number of botanical projects, which allowed me to spend a few weeks in the Amazon rainforest. And I think, like many people, you think of the Amazon rainforest as being the most biodiverse part of the planet, and so it must be rich with nutrients that supports this incredibly rich, fertile life. And of course, no further from the truth it is from that, because actually it's all built on a very thin layer of very sandy soil with very little nutrients on it. So that's why a buttressed tree, which is enormous, is there because the buttresses are because there's nowhere to put roots down. That's why it has buttresses. And the whole ecology of the rainforest is about being incredibly efficient with resource and using it in a very productive way. So I think for as architects, it's such a great lesson to learn from. And a project when I was in Glasgow I found really inspirational was the Keble Palace, which is this beautiful glass house. And glass houses have often been a way to explore and push the boundaries of architecture. And I remember taking Tony Hunt there when he visited once, and he couldn't work out how it stood up. And if you look at it, it's actually spiraling and slowly collapsing, actually slightly. But it is entirely a glass shell made of thin wrought iron connections and one layer of glass. And modelled, of course, on the Victoria lily. So, in many ways, it was an inspiration when we were doing the Eden project. So, for those of you interested, there's actually quite an interesting exhibition on. I went this morning at the RIBA called Difficult Sites, and it's exploring architects' responses to very difficult sites. And we had a very difficult site. So a couple of interesting guys. Jonathan Ball was an architect, and Tim Smith, who was a real driver, who was quite a force and become a good personal friend. But he had this idea of creating these giant enclosures to create an entire rainforest in Cornwall, and found this site that was it was actually coming to the end of its life. It was a English China clay quarry, and they were trying to get the last bits out before they sold it on. So it meant the site was changing form and shape, and we couldn't design a building to go into it. And so originally we designed it a little bit like Waterloo, but I was very keen to use what was a relatively new material then called ETFE, ethylene tetrafluoroethylene. It was a very lightweight polymer. It's an inert material, but it's it uses a fraction of the weight glass would use. So a glass and steel building was where we started, would have used this uses less than 10% of the same volume of material because it's so much lighter, the steel frame's lighter, there's no material in the ETFE. And again, this inspiration of nature, I remember Fry Otto had explored dragonflies' wings and how they connect, and so that was quite an inspiration for us. And then ultimately the idea was creating a form that was a series of interconnecting spheres, and soap bubbles always never change their diameter, their geometry, no matter what diameter they are as they interconnect. It's got an interesting mathematical science to it. And so the idea was if we made it in spheres, then it could actually connect with the quarry in any formal way, and we could actually change it, and it was a very, dynamic response. But the thing I've enjoyed about Eden is there's a whole collection of buildings. So everyone focuses on the biomes, but actually the first buildings we built we showed the visitor centre opened the year before the biomes, were made using traditional cob, if you like, rammed earth, using the clay from the quarry. And the reason it's pink is it was actually the original clay that was used for the FT paper, believe it or not. So it's interesting. So that's why it's that pink colour. And then we used rocks that we had excavated for the gabion walls and so on. So it's very much about being grounded in the earth and part of the landscape. But of course, everyone goes to experience, I guess, the biomes and step into the rainforest. And hopefully it allows a lot of people to experience the Amazon without having to fly there. So, you know, if you haven't been, I think it's an enjoyable experience. And there are also some lovely other gardens around there. And it's been an ongoing relationship with us now for over 25 years, I guess, working with Tim in various ways. So, you know, the Eden project has grown in its own campus, and we've done various other projects around it. It's just building at the moment a very deep well geothermal energy source that will actually provide all of its final power and heating now, and also the village of St. Austell. But for me, the most exciting part of Eden is the impact it's had on the southwest of England. So, I mean, it's hosted things like, you know, the G7 conference and so on, but it's actually created, outside of the project itself, over £2.5 billion worth of investment to southwest England and to Cornwall. And, and has been part of, I think, a real transformation over the last kind of quarter of a century in that part of the world. So we've now been working with Eden on a whole series of different projects. So the Guangzhou's the furthest ahead, and that's actually, I've only got old photographs, I'm afraid, but it's pretty well finished. But each one has its own theme and its own response. And of course, the latest, which I was very pleased about getting further funding in yesterday's budget, is Morecambe, which is, again, a seaside resort, if you like, town that's very much on its heels. And I think this will have a similar transformational effect on the local economy. I mean, Eden itself employs over 400 people in Cornwall, and then you can probably quadruple that on the impact it has locally. So again, hopefully this will have a similar impact, as well as being a real inspiration for the next generation about learning from nature. So a few years ago, I went to a fascinating conference with David Attenborough and E.O. Wilson, the Geographic Society, and little did we know, a few months later, sadly, E.O. Wilson passed away. But he coined this phrase, biophilia hypothesis, and for those who aren't familiar with it and his work, it's about our need as sort of living beings to reconnect, to be connected to nature. And if we live in cities that are just all concrete, with no, and we all experienced this during COVID, the real need to go into parks and to reconnect to nature. And so his work was about this importance of connecting to nature. And again, it's something that I think we've tried to draw upon in our work. So a good few years ago, when I was in New York, we were invited by Bloomberg's administration to put forward a competition for a new typology of affordable and sustainable housing. And we did this proposal with a guy called Jonathan, two developers, Jonathan Rose and Phipps. And so it was because they'd done competitions before and they never happened. And unless you have a client and a developer that's willing to take it forward, it's not going to work. So the idea was architects teamed with developers and put a joint proposal forward, and so this was our proposal. And the Bronx was one of the most challenged areas of any inner city in the US. The burning Bronx went through a period where literally buildings were being burnt down with arson for various reasons. So the city had this little bit of land, you can see that green slither, it's an end of an old railway line, but it was one of the last bits of greenery in the Bronx, and we felt it was a really precious commodity you couldn't lose. So our approach was to create this sort of ziggurat of terraces where we kept all of the greenery and just put it on the roof and created a series of gardens. And it was a very challenging budget because it had to be built for the same price as the standard cookie-cutter affordable housing they do in New York. So that took a bit of imagination. But we managed to hold on to everything. And because it was a narrow site, and again, that's why I found that difficult sites exhibition so interesting, because architects, when they have difficult sites, it's a bit like putting a bit of sand in for an oyster, it creates a pearl. If you have something to work against, actually, in a way, it creates more opportunity to come up with creative solutions. So that narrow site allowed us to actually have all the housing cross-ventilated, which is absolutely unheard of in New York. And because they're sealed units with air conditioning. And so, again, picking a little trick out from Corp, having the corridor every other floor allowed us to have every building to have cross ventilation from one side to the other. So the circulation corridors every other floor. And it meant that the buildings can open up to the greenery beyond. They can be naturally ventilated, and so these are 3 levels of affordability, from lowest income to different median incomes. And actually, the tallest part is purely rental, so it's for the lowest income, and then there are different levels of assisted affordability. And 10 years on, the building's really doing really well, and we shall see how it does this in the Architecture Today, I think, awards later next month, so we'll see how it does. But anyway, but they've continued to improve, add batteries to the solar system and so on. So it's really been a success as far as creating a community, and that was the core to our design, was this idea of community, because it was interesting. All the other architects that put forward proposals had different buildings for the different income brackets. And we felt it was so important that everyone was wrapped into one around a courtyard and shared, a garden space. So, the kitchens all look down into a garden space that's safe. There's only one entry point into it. Children play in, and then you can make your way up the kind of, there's a sort of amphitheatre area where they have performances and events, and then you make your way up to the different terraces. There's an orchard. The productive gardens are really popular. And as I said, the best part is the lowest income bracket get by far the best views. They get a view right back to Manhattan, which is really nice. So it's been a big success. And I think, as an architect, seeing how things can have an impact on community is so important, because we always like to think of ourselves really as being servants to society and to civil, to basically, creating the opportunities that cities need. And so, thinking more about just sustainability and using what you have, and again, this idea of ingenuity and ideas replacing technology in a way. I think another good example, and I've tried to pick different types of buildings. So this is infrastructure now, and this was again a competition for it's replacing an existing station in Melbourne, Australia, and. The reference scheme we were given by the government it was a large roof. There were diesel trains. They always all have that for a long time to come. So they had a lot of mechanical equipment on the roof to ventilate it, other equipment to keep it cool in the summer, and so on. And we were aware there were 2 quite strong prevailing winds in going across Melbourne. And so our thought was, well, what if, in the way that moguls are created or sand dunes are formed, if you took that and kind of reverse engineered it, you could actually take that form and shape of roof and actually use it to help ventilate and cool the space below. And so, often with these ideas, you have an idea, you can draw it, you can sketch it, but, of course, you then go on to CFD, computational fluid dynamics, to really test it, and you do wind tunnel tests and so on and so forth to make sure it works. But the initial idea held true. And so, indeed, the roof form and shape is entirely about creating a performative response to the space below it. And part of the reason they were replacing the building was to change because it was change how the city related to it. And so it was one of those classic examples where the tracks were cauterizing the city, and they wanted the docklands to be redeveloped. So we wanted to reconnect the docklands to the city. So really the roof became the fifth elevation. Everyone looks down onto it, and by looking at the levels and so on, we got rid of the bridges and just created almost really a kind of illusion that you flowed from one side to the other without any, and you did not read the train tracks by changing levels, and so effectively sunk the station to a lower level. But the main thing is, what we're going to look at today is the roof. And I remember, I think, there's that old saying, just because you can doesn't mean you should. And at that time, there was definitely a movement where people were, because we have these great computational design tools, people use parametric design to create really complicated shapes, but purely for the sake of it. And in my mind, nature doesn't do that. Nature always responds in a very performative way, in using the minimal material in the most efficient way it can. And by doing that, it has an inherent beauty. And I think if you capture that in your work, so there's a reason behind everything, then there'll be a more ingrained and natural beauty within your solution. So here, the sculptural form, it gives a landmark and a place for an important building in Melbourne, but the shape is very much driven by actually what it's doing. So that that idea of using your mind to solve the problems rather than just relying on technology, I think is something that we're really keen to explore. And I think people looking from the outside in think that we just look for technological solutions and apply them, but it's actually can't be further from the truth. So that's why I've picked a few projects to kind of illustrate that. So this is another competition. I think that's Zaha's building at the back there. She was one of the competitors, I remember. If we go to the bar afterwards, I'll tell you a couple of side stories to that. A wonderful architect, sadly not with us now, but it was a kind of an ideas competition, and we were really interested in how the building could be part of the science, and it was a lovely little science museum, but they got this grant to build a new building by the ocean, in a bit of reclaimed land. And we thought the kind of landscape and its relationship to the sea was the key to coming up with a solution. And really thinking of the landscape in Florida and the kind of topography and creating this connection back to the kind of, what is their climate. And so we were lucky to get a Department of Energy grant on top of our fees to do additional research work to see if we could reduce the energy by at least a third. So museums typically, and particularly ones with aquariums, use a lot of energy. Aquariums are and believe it or not, you have to cool them all the time. So they use a lot of energy. So we thought, well, actually, it's a very benign environment in Florida. It pours with rain in the afternoons, but the sea breeze keeps everything cool. So actually, if we could rethink and have all the circulation of the building actually open air, it means we only have to air condition the actual exhibit bits, if you like, which immediately cut the energy consumption by over a third just by doing that. So we did, of course, little sketches and ideas with, of course, backed up with computational fluid dynamic analysis and so on. But it allowed us to actually have all of the circulation. So all that you see here is actually outdoors. The escalators, the elevators. Part of them is sheltered above because you have these downpours of rain, but basically it relies on funneling. So it's a funnel that takes the sea breeze through. So there's a constant breeze running through that keeps it cool enough to make it pleasant for everyone. And what's wonderful then is, rather than being in this box, cut away from the beautiful Floridian landscape, when you're up at the higher levels, you look out to the ocean. And so you can look at the ocean. The top of the aquarium is actually open to the sky. And then you go down and explore it through the different exhibits. And then when you come to the very bottom, you then look up to the aquarium. And we wanted to create this illusion, which actually I should have put some little sketches in. It was inspired one evening in a bar in New York where we were looking at martini glasses for some reason. And New York does very good martinis. And so we realized if you created the walls to the aquarium that slope outwards, when you look in, you'll never see them. And so you can create the illusion that a diver has when you're looking from the bottom up. You just see the expanse of ocean. You see the fish swimming round. And so that's the illusion that we kind of created. And again, I mean, these buildings, it's the impact they also have, locally and on the local kind of economy is just really fascinating. So I mentioned at the beginning, new build's part of it, and of course I think there's a much greater awareness, particularly in this country, less so elsewhere, of the importance of reusing what we can reuse with adaptive reuse. And actually, again, I think people think we do a lot of new buildings. Probably a majority are actually working with old structures, because we do a lot of railway buildings which generally were built 100 to 200 years ago. So we often were working with, like London Bridge, working with existing buildings. But it's really interesting to go back and work on one of your own buildings. So one of Nick's earliest buildings, when he was with Terry Farrell, was a factory for Herman Miller. And it was inspired at the time by this flexible furniture system called Action Office. And the idea of the building was you could actually change it, and the panels could move. And actually, during its life as a factory, they moved the cladding 8 times as they moved different operations around, because it had a view out onto the River Avon, and so you wanted to have the windows where people were and so on. So it worked very well for them. They eventually needed a bigger facility, which we designed for them, and then the building was actually sold to the Bath School of Art and Design. And so we were then tasked to convert it to now, building of today. So it's no longer a factory for furniture, it's a factory for creativity. And it actually works really well as a factory for creativity. So we took all the panels off and upgraded them. So the whole building now performs at the very highest levels of specification for today. And I think it demonstrates it. It was pretty well out of 50 years of use at that point. Is that hopefully it will have even longer use now in a really efficient way as a school of art and design. And again, it demonstrates, I think, what we need to do to our existing building stock, that you can upgrade it and you can change it and you can find new use for it. So I mentioned, we've been kind of exploring this work really since I've been with the practice. And I think the last decade has been really important for us. So, as I mentioned, we made this commitment in 2019 of all of our buildings being net zero ready by 2025, which we're pretty well on track for. And so we've developed a series of buildings in different continents. So we're going to just talk about 2 or 3 of them now to finish off with. But in Australia, in the Middle East, in different parts of the US and different parts of the UK. So it's given us the opportunity to understand and explore what doing a net zero ready building means and an environmental response in very different climatic locations. And so we thought what we need to do, we had to develop tools that allowed us to actually, there's a kind of science side to it where you need to audit what you're doing and actually come up with an audit trail. And of course, the big thing that's happened, I think, over the last 6 to 7 years is an increased awareness of the importance of embodied carbon on buildings and not just operational carbon. So up until 6, 7 years ago, everyone was very focused on how efficient can your building be. And more money's gone into making buildings efficient, actually, but funny enough, sometimes at the detriment of their embodied carbon. So at the moment, buildings probably put out between about 40% of global gas house emissions, and about half of that's housing and half of it's the rest of the building stock. Currently, embodied carbon's around 10%. It's now, it will double very quickly to 20%. So the embodied carbon part is now becoming a very large part of the building. And almost no country legislates for embodied carbon. I think there's an except, probably the Netherlands are one of the few places where they do whole carbon analysis. So they're looking at both the embodied carbon and the operational carbon of a building. And carbon energy, there's, you can look at it different ways. So the problem is, there's lots of rules about how efficient a building has to be. There's nothing on what you make it out of. So you can pour in as much concrete as you want to. And recently I was judging a competition, I won't name the building, but it had won quite a few awards, but I've never seen so much concrete used in a wasteful way. And I just thought, the embodied energy in that building is just absolutely outrageous. So I thought you just can't, we need to move on. So we've developed tools, and we got so far on that. And we decided, we ended up actually creating a relationship with the World Green Building Council, helped fund and support us to develop a new kind of operational analysis tool, which we've called Monoro. And you can look it up after this. I'm not going to go into a lot of detail because it's a whole talk in its own right. But it allows you to track and analyze carbon. And it's because we've worked in different parts of the world, we worked with over 90 different consultants and people and agencies, the AIA, the RIBA, AIA in Australia, etc. So it operates in all the regions that works in Europe, America, Australasia, the Middle East. And it also works for all the different users involved in making a building. So for clients, for cost consultants, for engineers, for architects. And as I said, it's open source, it's available to everyone, and the more people use it, the better it will get. And we felt the only way we can change the tide is we've just got to share everything that we can share and actually promote and get try and get as many people on the same side. So just a couple of projects just to finish off on that. This is the Monash TED building in Melbourne. It's a research building for science and technology. And I think it is the largest passive house in the southern hemisphere. So it has some very interesting kind of pedagogy models of different types of teaching now, different lecture halls, different ways of exploring academia and so on. And it was incredibly fast building. We did it with Lend-Lease in just over 2 years, from start to finish. But nevertheless, we managed to keep all of the environmental standards, both in its operational content and its embodied carbon content. So, the majority of the steel is recycled steel and so on. So, it's been very successful, and that's one of the buildings that, we've drawn on. Another one, the Walton Center for Planetary Health at the Arizona State University, again, learns from the environment it's in. Again, the environment in Arizona is actually, it might be hot, it's very dry. And so, the original spec I think we got was to have a big atrium space surrounded by lots of labs. Now, labs are incredibly energy intensive, so to try and do an environmentally sensitive lab is a lot of work. And again, we realized, well, actually, there was a canal running through the site. We would have to move the canal. It had all sorts of interesting features. We thought, why don't we just lift the building up, and actually the landscape and the atrium could just be open. It's just Arizona. And Arizona is, the climate's actually quite beautiful. And we just created almost a kind of a landscape interior. So the core is open. And then the building responds, of course, to different, each side of a building is different. It has different, the sun lifts up on one side and drops on another. So the modernist approach of every side of a building being the same isn't the right approach. So here's the center. As I said, the canal just runs through it. The landscape runs through it. You kind of you come into the building, and then the labs circulate around that. And every side of the building, again, we were kind of inspired by cacti and how they deal with sun and shade. And again, it's this sort of idea of a layering of facade. That each facade is different depending on its orientation to the sun. And so again, the building's surface is also now responding to its location. And embodied carbon is really important. So we tried to reduce the amount of concrete, and a technology we used on the building we're now going to look at next, the Sustainability Pavilion in Dubai, we used a technique called bubble deck, which you can see here, which reduces the amount of concrete by about a third, but it also makes it lighter, and so it means you're putting less load on the rest of the frame. So it takes concrete out. So, they're just technologies you can use to reduce the impact of your building. So the last building I'm going to look at is the Sustainability Pavilion, which is one I got personally really involved with, and it was just a fascinating competition. So, we were asked with 5 other architects to put forward a proposal for a sustainability pavilion, which would be the anchor for the World Expo in Dubai. And so, the Emiratis are actually quite clever. They don't invest money and then throw it away. So, for instance, the Expo in Milan, they're still trying to figure out what to do with it. They took a different approach. They actually designed the permanent solution first, then worked backwards into the Expo. So the Expo had three zones. We were in the middle, sustainability. Then there was, I think, mobility and opportunity. So these 3 zones, and they were all to be permanent, with a view that this will become a permanent city, and it's an extension to Dubai, which is now happening. And of course, you may have read that they're making some big moves. They're actually moving the airport from one side of the city to this side of the city. So this will now become a kind of aerotropolis and a new kind of incubator innovation district for Dubai. But 6 years ago, that was what we were given. Literally a bit of desert, and that's the story of Dubai. We were talking about this earlier on. It's just an amazing place where transformations can happen very quickly. So in 3.5 years, they built 250 buildings, the equivalent of the West End of London, actually, of that part. It's quite amazing what was built. So our approach was, let's really demonstrate in the world's harshest climate that you can do a true net zero building, triple net, that generates its own power, generates its own water, deals with all of its own waste. And if you can do that in Dubai, in the desert, in such extreme conditions, you can do it anywhere. And there were 25 million people did actually come in the end, despite COVID. And it's still, and of course, it's open now. It's a permanent research and exhibit centre. So again, the first thing we did, and this is about idea, is that actually design your way out of the problem first. So most of the building had to be was black box exhibition space, so you could actually sink that below the ground. Immediately, it means you're in a much lower temperature environment. So you've dropped your cooling load, so you don't need as much cooling. And you work with the landscape and work with those sorts of things. So actually, all of the building is below ground effectively. So half the building is literally below ground because the site was regraded. And the rest, we took the landscape up over the roof. So it sits under a very heavily insulated garden, effectively. And then sitting over that is the canopy that keeps the courtyard cool. And again, the way we like to do these things, the circulation is all open to the air. And the canopy helps, cool that. And it does a number of things. So you can see there the landscape going up, round and over, and then the canopy floating over that. And it helps direct breezes through the site, and it really keeps that courtyard several degrees cooler, and moving the air through it makes it much more usable throughout the year, as well as, of course, then harvesting energy. So that was the idea of the kind of canopy floating over the building, and it was kind of inspired by the gaff tree, where you get these trees with deep taproots that can be in the middle of the desert and provide this beautiful shade. So this was our kind of gaff tree, harvesting energy and providing shelter and shade. So again, we had about 3 years to build the building. So this is, you go down before you go up. So the whole site had to be regraded for various reasons. So it meant we could create this kind of underground section to the building. And I was quite keen that also, the idea of collecting water would be a central part of the building. And you'll notice I still really like doing isometric drawings, and that comes from having 2 years of working with Jan Kaplitsky. And every drawing I did had to be an isometric. So, but we also wanted to reduce the weight of the steel was all mostly recycled. We actually halved the load of the steel in the building and really tuned the building as much as we could. So the canopy is actually really light, very, very lightweight, and it just supports this sort of glass skin that has the inbuilt photovoltaics. And the cladding is all reclaimed as stone from a nearby mountain range in these gabion walls. So half the building is underground, the other half is just stone. So we've kind of reduced, if you like, the embedded energy in the envelope and cladding. And of course, the one kind of technological intervention we need is harvesting the sun to power the building. But the roof wasn't enough to collect enough energy to do a whole year because the cooling load, particularly in the summer, is quite high. So we were quite inspired by these dragon trees from the kind of Yemen Peninsula. And so we did these, what we call energy trees, and they're kind of dotted around the landscape. So they help shade the landscape like floating trees, but also harvest another third of the energy. And they're much more efficient because we used a carbon fiber to make them as light as we could, and that meant we could put them on a gimbal. So throughout the day, they track the sun. And at the time, I thought that'd be great because it's an expo. There'll be like kinetic sculptures. People really enjoy seeing them move. I hadn't really thought, well, yes, but they move over 12 hours. So unless if you go back and come back 3 hours later, you say, oh yeah, they've moved. So, but nevertheless, they do what we wanted them to do. So they kind of harvest the sun as the sun goes around the building. So they're tracking it, but also, of course, maximize the shading in the garden below. Here we go. So these, I think, are speeded up so you can actually see them moving properly. When I was designing them, I thought that's what they would look like, of course. But anyway, and they're what was referred to as bifacial PV. So they actually get energy both on the front and the back because you get light bouncing off for those. So they're even more efficient. And so, as I mentioned, they go around the site, they help shade. And then the landscape, we wanted to be an integral part of the whole experience. And we worked with our friends at the Eden Project, and a really great firm we've worked with a lot since called Desert Inc. And they went out into the desert and found plants that hadn't been used in landscape. They basically, the desert's full of seeds that only germinate when it rains, and they just explode. And so we wanted to create a xeriscape. So in other words, not a landscape with grass and deciduous trees from another part of the world, i.e. here, transplanted into the Middle East, but a landscape that's all about the indigenous material plants of the Middle East. And so I think, it uses very little water, and yet it's actually, in my mind, even more, full of, colour and vibrancy, and really, again, we're talking about that kind of sensual experience of being immersed in a space. So just finishing off a few pictures of so this is the main looking down from the top of the highest part of the roof into the landscape roof into the courtyard. And during Expo, we brought people into the courtyard and split them up so we never had a queue. And so it was probably about the only pavilion. It had more people through it than any other pavilion, but never had a queue. And we did that by getting people to go through the building in different ways. I won't go through the exhibitions. Again, we worked with Eden on the kind of ideas of exploring Johan Rostrom's planetary boundaries. So we worked with Johan's team and Eden on the themes through the exhibition. So part of it's, you go through the forest, it's all about the root systems and so on, under the oceans and so on. When you finish the exhibition, and I won't show it, because if you all go to Dubai, you'll see it. It's all there, you can experience it. You then come to the centre, that I started with, and you come into the outer core, and then you make your way down into the inner core. So that's the very heart, so it's the lowest part of the building, where you look down on the water that's being generated. It sits over a pool of water. And so from there you can look down into the pool of water, and then you can look all the way up through the building to the sky, and so you get this connection of water and sky. And then we added some some elements, like, which was just as well a amphitheatre, which has been really heavily used since, and of course it then hosted COP28, so this is where the World Leaders Forum was held. So now it's a permanent building. You actually enter it into where you used to leave. So you enter into this space, which is the main entry space, which you can see here. So you come into this entry space and you look out into the courtyard, and then you circulate around the building. So as I mentioned, it's now there as a permanent kind of research centre and institute, and and a kind of science centre, if you like, dedicated entirely to sustainability. And because we've now run it for 2 years, we now know it's actually net positive. So it actually, over the balance of a year, it generates more power than it uses and puts a net power into the system. So finally, I thought I'll finish off with my epilogue. So we did this is the epilogue. So we started off in the village of Dollar, and so I'm going to finish off with the village of Dollar. So a few years ago, I met the new head of the school, very young guy called Ian Monroe, in Boston, looking at this really interesting school that was set up by architecture PhD graduates from MIT. And it kind of teaches school kids in a way you would, the AA teachers. So they actually work on projects, they work in teams, it's continual assessment, and it's had incredible results, and they've gone on to all sorts of great universities afterwards. It's been running for a few years. So using that, we thought we'd develop a kind of educational program in a centre, and then COVID came along, so it was put on hold, but online teaching happened, and they found they were quite good at it. So in conversations with Ian, I thought, actually creating a set of courses around the UN's SDGs, the Sustainability Development Goals, gives something for everyone. Because, if you're interested in science and technology, the environment, you can do that. If you're interested in inclusivity and politics, there's something for everyone in every course. So the online courses, and we've developed a couple, have been really successful. They've had well over 800 kids over the last few years doing courses directly, over 100 schools with classes. 20% of the schools are in economically disadvantaged economic zones in Scotland. So it's had a real impact, and actually the really pleasing part is it's now been picked up by the re-look of the Scottish education system, and it's a model they're wanting to adopt and reincorporate into a broader reassessment of education. And just a few months ago, we announced that basically it's the first internationally recognised sustainability diploma. And so kids can do a diploma in sustainability. It's accredited by Stirling University. And it's the equivalent of doing a higher, let's say, or an A-level here in England. So, it's had a great impact. And so we've now come full circle. We're now doing the centre that we started off doing but couldn't because of COVID. Back there. So again, the centre will be available to all the local schools and across Scotland. But it had a little bit of a problem for me in that the original building was built by a well-known Scottish architect called Playfair, who also did the Edinburgh National Gallery, the Scottish National Gallery in Edinburgh. And both his father and he did most of classical Edinburgh one way or the other. So it's a Grade A national monument, and historically, you could say sensitive to putting a modern building beside it. But I thought it was really important that the building, because it was kind of available to everyone, should be front of house, not tucked somewhere at the back. Unfortunately, I mean, sometimes luck plays a trick as well. The planning, the officer from, I always get it wrong, it's now Historic Environment Scotland, they keep on changing their name, equivalent of English Heritage, I worked with previously in Westminster, he was now there, and so we had a great dialogue about would a modern building sit opposite the school, and he did some research as well, and we found, the building was originally built in 1819, and in the 1850s, it was actually surrounded by a botanical garden. It was part of the teaching. So, people then were really connected to nature. So the gardens were an integral part of that kind of learning process. And so we thought, well, if we recreate that, environment as part of the solution, and then in a way, a sphere, a dome is quite a classical kind of response, and we could do it in a very contemporary way, but yet it's kind of, it's a kind of, I guess, a classical icon, if you like. And also it allows us to do a really lightweight, economical, big building. So it's a glulam kind of dome with ETFE and so on, but really surrounded, and I'm really excited about the landscape part as well. It's immersed in this landscape, so it sort of sits in the landscape. So it's a very conservative village in many ways, very traditional, I should say. My brother now lives there, and he said, if anyone says I've got the same name, I'm going to say it's by accident, because he was expecting to be vilified about putting this modern building in. But it was the exact opposite, and actually had huge support, went straight through planning, and we're hopefully now starting construction next month. So, so there's the Ochil Hills in the background, and it has that kind of soft form. And I suppose in many ways, there's the kind of, the building, the classical building in the backdrop there, and by Playfair, and then we have our building in the foreground. So this is a little model we had at the RA, and then hopefully in about 18 months this will be the kind of spaces we'll have a really different kind of learning experience, doing, I think, exciting hands-on making things and solving problems, and really I hope bringing our future leaders, our next generation, to lead us out of the problems that we've created over the last 2 generations. So with that's my epilogue, and thank you.
Well, comments and then a question. Andrew, it was great to see that, and I remember the diploma days, and I think you and I started teaching more or less the same year. And it's been a long journey, but you've been really consistent in exploring those boundaries all the way. So one of the questions I have is that the scale of the projects is increased from, and do you miss the small works?
Well, that's why I'm enjoying this one so much. Yeah. Very tight budget, but yeah, and actually, I mean, the first project I did, I think it was the home-based project probably, and we designed. It was 3 people, and we designed and built it in about 18 months. So, for a young architect, it was very rewarding. And one of the things, I mean, we obviously won we won Sterling Prize recently for the Elizabeth line, but that was probably about 15 years or so, 12 years or so. So they're long. Those, the infrastructure projects take a long time. And I think particularly for young people working on it, what we try and do is also bring in. That's why this project's been great. It's mostly a team of just recently out of college, students working on it. So it's because for them, we'll design and build it, and they'll see it done in 2 years. So yeah, I think doing small scale projects is really rewarding. But we have to do infrastructure, and so you just have to be very patient. But you do need one to survive the other, I think.
If there are no questions, I do have a question. Oh, you do? No, go for it.
From your experience, what are the challenges of doing energy-efficient buildings with a tight budget? And how do you circumvent these problems?
Actually, I'm going to answer it, but in a slightly different way. It's like being a politician, isn't it? We've been trying to, for instance, recently use the Living Building Challenge as part of our kind of environmental design standard, which is probably the toughest one to use. So it goes beyond just energy efficiency. You have to basically generate your own energy, you have to recycle your own water, you have to look at the materials you use and so on. But my criticism of it is it looks at buildings individually. And I think the only way you can really truly solve and have environmental responses is to think of networks. Because, and my criticism has been back to them, and we actually end up dropping some of it because it makes no sense to try and generate all the power of a building in Scotland using PVs. Because Scotland's much more suited to using wind power and hydroelectric and other sources. And you can only do that as a network. So I think the more we think of networks and actually invest in infrastructure that distributes energy and so on, then it'll be much easier to have a solution. Because actually, technically, if the investments that's been talked about with our new Great British Power, we will be almost, that we could easily generate all the energy we need through wind power, and then some other sources like hydro and so on. And so it's all about infrastructure and distribution, and then it takes the pressure off the individual building. Because if you try and just cover a building with PVs in let's say a very temperate environment, it's not going to solve the problem.
Hi, Andrew. Klaus is my name. I was going to touch and ask a question exactly what you're talking about now.
Right.
So just on that, because when you go back from the beginning of your talk about the growth, population, urbanization, the challenge of every builder being self-sufficient is almost utopian, to be correct. And you've got wonderful buildings here, and I'm an engineer, so the creation of this engineering and architecture embedding into one piece, that what it can deliver. So the knowledge is there, the technology is there. But one of the things I wanted to ask you as an architect is, I believe the planning laws are a problem, because the answer to solve this decarbonization sits in the synergy of infrastructure and buildings. And planning gives you permission to do something on your site, and they don't like to say, oh yeah, I'm going to contribute some money for some infrastructure project. So my question is, how are we going to sort this problem where the answer to a number of engineers sits in the synergy between an infrastructure development that decarbonizes, uses its natural resources wherever. You use the right word, networking. We talk about smart cities and we talk about smart buildings. I always joke, nobody talks about smart people. I never understand that. But somehow bring that networking together with the individual development city, because that same strategy of networking is a solution to certainly developing countries where they don't have much of an infrastructure and you have an exploding population. So I don't get how can we convince politicians or through the architecture in somehow, whether it's through planning or whatever, to bring these two elements together. I don't know whether through your experience you've thought about or maybe have an answer to that.
Yeah, I mean, the frustration I think we often have is that, the agenda set by politicians who have a timeline that's basically their electoral cycle. So they can't think longer than 4 to 5 years. And most of these investments take 20 or whatever. And so that's, I think we're hamstrung that way, in my mind. I mean, we were obviously working on the high-speed rail too, and we're working on Euston, and then one government just didn't quite suit them, so they stopped it. Now another one wants to start it, so it's now going to cost twice as much as it would have done if they kept going. There we are. So I think big thinking. It doesn't happen that often. One of my fellow partners and great friend Keith Brewis has been working on a kind of national plan. Hopefully we'll get it going. But thinking for instance, if we're generating a majority of our power through wind, offshore wind in particular, why are we then spending vast amounts of money trying to build an infrastructure system to take that power back to the way we had organised the country around coal-driven power, to conurbations that were only there because of coal and because of mills and so on. So surely we should actually grow as a coastal country because actually our relationship is now with the coast. And then you can just take it straight to coastal points and have that relationship. So, but to do changes like that takes big thinking, and I think that's the issue. Is you need.
Does lobbying maybe help with it?
Yeah, I think so.
Education, knowledge,
yes,
yeah. Together with, and I'm sure you get friends through architects and some kind of lobbying.
Yeah. No, I mean, yes, we've been. No. No, well, we're at the stage of listening with our current administration. We've been along, yeah. So no, I mean, I think there is. I think we'll wait and see. I think there is an openness to bigger plans and to investment in infrastructure, because that's the only way is that we need to. And yeah, I mean, I live in the US and look at the economy there. It's even more short-termism, and the reason why literally bridges fall down is no one wants to put money in infrastructure because it doesn't win votes. And so no one, I mean, there's no high-speed rail in America for a very good reason, because no one invests in the railways, So until you get long-term thinking, we won't make the moves we need to make to really sort the problems that we're facing. I mean, it's interesting, isn't it? Is democracy the issue? I don't know, because in countries, such as China, they do much longer-term investment in infrastructure. And actually, similarly, we can do things in the Middle East we can't do here, because decision-making, there's only a few people make big decisions, and they can make 2030 plans and 2050 plans.
Maybe sustainability demands a different kind of decision.
Yeah, well, I think it does, because it's long-term, yeah.
Thank you.
Yeah. Hello, thank you. I think this is a great look at maybe how you take environmental conditions and through CFD and at such scale that you can embrace ingenuity, like for these buildings. And with ETHE, I think that was such a fantastic solution through materiality. And I just wondered if there was anything else on your radar as far as novel materials that you're trying to introduce within the buildings moving forward.
Right. It's not so much materiality. I think it's more using. We're now looking at using AI to become more productive and more efficient, and so sort of computational tools maybe more so, because in many ways I suppose there's a greater interest in going back to using materials like wood, but in different ways, whether it's cross-laminated timber or glue lam and so on, but in more efficient ways. I'm just trying to think. Is there any? I can't think of a magic material we're going to get quite soon, but I'm sure there are things we're working on. But yeah, well, actually, we just did a project recently that got longlisted for the Earthshot Prize, which was we worked on with East London University, was reusing waste from sugar beet and turning that into a building product. So so I think there's all sorts of things like that. I mean, the area I'm interested in, and I've talked to Johan Rostrom about it, is taking the planetary boundaries and actually turning that into thinking about design and architecture and creating a kind of architectural education program at least around it. So going beyond just thinking about energy and carbon but actually more holistically. Because as I mentioned earlier, for instance, I mean, even ETFE, there's an issue there because it's a polymer, which is a material that never. I mean, it's great. So Eden, 25 years on, it's all perfect because it doesn't degrade. The issue is in its production, and DuPont first manufactured it around the factory there. The waste products had all sorts of impacts because it doesn't disappear. So if dairy cattle get it, you can't use the dairy cattle, which has happened in the States. So I think I had no idea until about a year and a half ago of the impact on the production and waste, for instance. So that we need to gather more knowledge, I think, more holistically about the impacts of the built environment beyond just thinking about energy and carbon. Probably it's a good point to make our way for even deeper discussion upstairs.
Absolutely. Thank you so much, Andrew. We continue at the bar. Thank you.
Great. Thank you.